Yeah, that'll work. All right. Excellent. Good morning. Sorry to keep you guys waiting there for just a moment. Just finishing up some stuff for today. So today we're gonna do our kind of like practice with the things we learned about confidence intervals yesterday. So it might be good to have your notes available so you can refer to those. I also did post the study guide for section 8.1 yesterday, so that is in the resources for section 8.1. And so there's that available if you'd like to look at that in Canvas. That's an option. All right. So we are going to get started. And hopefully this is helpful. We'll do some examples, we'll see some examples, we'll practice with this stuff and answer any questions you might have. All right. So, yeah, let's get started. So here we go. In 8.1, confidence intervals, the basics, we're going to do some examples and practice problems. All right. Let's get the link in here one more time. Yeah, the link should be in the chat again in there for you, Wesley. Please check the chat and it should be available. Or you can go to joinpd.com and use the letter code right here, IYNPZK. All right, so here we go. So example 1, we have our hot dog fat content. All right, this is actually the CYU, the Check Your Understanding from the textbook in section 8.1. So here we have, how much does the fat content of Brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 hot dogs. A 95% confidence interval for the population standard deviation is 2.85 to 7.55. Right. So our job is to interpret the confidence interval, interpret the confidence level, right, and then answer this question, true or false. The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. Justify your answer. All right. Hopefully this works the way it was supposed to. Yes, excellent. So for question number 1, all right, the researchers are 95% confident that the interval from 2.84 to 7.55 grams captures the actual value of the standard deviation of the fat content of Brand X hot dogs. That's what the interval tells us. We think in this range of values, we are 95% confident that the actual standard deviation is in there somewhere. We don't know exactly what it is, but it should be between those two values. We're 95% confident. So that's the interpretation of the interval. Right? When we look to interpret the level, that's slightly different. Right? If many samples of 10 hot dogs were taken from Brand X, and that's kind of an important part of this interpretation, is saying like if we redo this sampling over and over and over again, about 95% of these samples that we get will result in an interval that captures the actual standard deviation of the fat content. So that means some of the samplings that we do might not give us this interval that hits the standard deviation, but about 95% of them will. And so that's how we interpret the level of confidence. And then our last question here, the true or false question. Right, this is false. This particular interval either does, probability 1, or does not, probability 0, contain the actual standard deviation. right? So making the statement that the interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation is an incorrect statement, because that particular interval either does have it, 100%, or does not, 0%. All right, that is different than what we said in question 1 in part 1 about interpreting. All right, that's our confidence that the standard deviation is in the interval. We're 95% confident, right? But to say there's a 95% probability or 95% chance is incorrect. So in this question, right, you need to determine the point estimator. Right? Are we talking about the sample mean, sample proportion, X bar, P hat, whatever? And you're not gonna be able to use that notation in here, so just type what it is: sample mean, sample proportion, sample standard deviation, whatever, what have you. You would use to calculate the value of the point estimate. All right. All right. So you have to determine the point estimator and then the actual value of the point estimate for the context. In our context is Tanya wants to estimate what proportion of the seniors in her school plan to attend the prom. She interviews an SRS of 50 of the 750 seniors in her school and finds that 36 plan to go to the prom. All right, so what sample statistic do you think we would use in this scenario? And what would be the value of that estimator? Alrighty, guys. So a lot of you guys are on the right track here. We're gonna discuss this one now. We don't have a solution slide here, so I'm just gonna have to tell you guys. So in this context, right, we would use the sample proportion, or p hat if we could do the notation in this in Pear Deck, because that's what we have. We have a proportion of our sample, right? 36 out of 50, right? So our point estimator would be the sample proportion, and the value of the point estimate would be 36 out of 50, or 0.72, 72% if you want to do percentage. Okay. So anything I can clarify on this example or in this question? Do you guys have any questions so far? This is where kind of like the whole confidence interval thing starts. It's establishing, what am I using as my estimator? That allows us to start doing more work from that point. Okay. All right. Yes, Caesar. Sorry, there's a hand up.
Repeat that.
The solution?
Yeah.
Yeah. So in this context, we would use the sample proportion, or p hat, because we have a proportion of seniors that we know want to go to, or planning to go to prom, 36 out of 50, right? We didn't find an average. There's not a mean provided here. We can't calculate a mean based on this context. And we don't have information to find any other estimator. So we'll use the sample proportion, and the estimate, the value of the sample proportion, the point estimate, is 36 out of 50, or 0.72.
Okay, thank you.
You're welcome. And this would also be a good time if you guys are taking notes or you're adding to your notes. If you want to record these problems and their solutions, or any notes you have about what's going on, this is a good time to do that as well. Does anyone have any other questions or need a moment to write things down before we move on to the next problem? already. So then we're going to do, I'm going to work through an example next. And to do that, I'm going to switch over to OneDrive. So if you guys want to make sure you're viewing the shared screen and not your own screen with Pear Deck, that would be suggested so you can follow along. And so we are going to do that. Let me make this bigger. Let's make this a little bigger. That works. All right. So we're going to look through this example, and I chose this example because it has a lot of different parts to it that will hopefully give us an idea of how to answer other types of questions and use the confidence intervals a little bit more. So this one has a rather long context, so we'll take a moment to read that. So this is based on scores of a particular type of standardized test. Young people have a better chance of full-time employment and good wages if they are good with numbers. How strong are the quantitative skills of young Americans of working age? One source of data is the National Assessment of Educational Progress, NAEP, Young Adult Literacy Assessment Survey, which is based on a nationwide probability sample of households. The NAEP survey includes a short test of quantitative skills covering mainly basic arithmetic and the ability to apply it to realistic problems. Scores on the test range from 0 to 500. For example, a person who scores 233 can add the amounts of 2 checks appearing on a bank deposit slip. Someone scoring a 325 can determine the price of a meal from a menu. A person scoring a 375 can transform a price in cents per ounce into dollars per pound. All right, suppose you give the NAEP test to an SRS of 840 people from a large population in which the scores have mean 280 and standard deviation 60. The mean X bar of the 840 scores will vary if you take repeated samples. So lots of context for the actual things we need is this last paragraph here. And so just as far as like some stuff that could be important, we have a SRS 840. This is really wide. And we have a mean 280, standard deviation 60 from the population. Right, this is the population mean and population standard deviation. Right, and then we have the mean X bar, right, of the 840 scores will vary if you take repeated samples. So X bar in this scenario, right, that is our point estimator, right? My pens are so big today. Right, so that's what X bar is going to be. They've kind of given that to us in the problem that we're going to use X bar, right? In A, we want to describe the shape, center, and spread of the sampling distribution of X, right? So, yeah, so we're going to describe the shape, center, and spread, right? We want to do a couple of things first, right? We want to find the mean of X bar of the sampling distribution of the sample means, and that's going to be equal to the population mean, which is 280, right? And this is from chapter 7, right? The 10% condition is met because we're just told this is a very large population, so we're going to assume that the 840 people is less than 10%. So we're going to say the 10% condition is met. So the standard deviation of X bar is going to be 60 over the square root of 840. And we get 2.07. Right, we need these numbers to describe the distribution. We can't just talk about it without having a mean and standard deviation in this case. We also have since 840 is greater than 30, central limit theorem says that the distribution is approximately normal. Right, and so again, this is from chapter 7. Everything in this first part here, before I've actually written my response to A, is chapter 7. Find the sampling distributions, mean for the sample means. We got the standard deviation of the sample means. And we know the 10% condition is met, and the central limit theorem says that this distribution will be approximately normal. We don't know if the distribution from our population is normal. They didn't tell us that, so we have to check the central limit theorem. Now that we have all this, we can answer our question. All right, so the sampling distribution of X bar. Sorry, guys. Getting a notification, I don't know. My Teams is like not updating. Yeah, Caesar, what do you need me to repeat? At what point?
Oh no, that was before when I raised my hand. It's okay.
Oh, okay, yeah. I don't know why my Teams on my side is lagging on the like chat and things. I'm not sure why. Because it just popped through. So I apologize. All right, so our sampling distribution of X bar will be approximately normal. With mean of 280 and standard deviation of 2.07. And that right there describes the shape, center, and spread. Saying that it's approximately normal includes that it's unimodal, right? It's symmetric. All that's encompassed in approximately normal. We know the center is the mean at 280, and the standard deviation describes the spread. So we're done with A, right? We had to do a lot more kind of like legwork to get this. This one sentence describes shape, center, and spread. Then, question B. We're going to sketch the sampling distribution of X bar, mark its mean and values 1, 2, and 3 standard deviations on either side of the mean. Right. This will be a rough sketch. Too wide. 280. And we'll go the other way. 280. And this should go something like this. Hooray! All right, close enough. All right, so there's our sketch. We got our numbers, we got our values, we have our sketch. Excellent. And we've marked all our values we want. Cool. So then moving on to part C, according to the 68, 95, 97 rule, about 95% of all values of X bar lie within a distance M of the mean of the sampling distribution. What is M? All right, let's just put this here. So M equals 2 times the standard deviation, which is 2 times 2.07. We get 4.14. And if we want to shade this, right, that's going to be this area in the curve. That's our 95%. Okay. Said shade the region on the axis. I should have read the entire thing, but anyway, that works too. If we did this appropriately, we would have just kind of like done one of these things, like an interval. Cool. All right, and then part D, whenever X bar falls in the region you shaded, the population mean mu lies within the confidence interval X bar plus or minus M. For what percent of all possible samples does the interval capture mu? All right, and this is about 95%. And this goes back to our confidence in this, right? We're about 95% confident that this interval contains the actual mu. I'm sorry, the confidence level. About 95% of all the samplings we could do should have the mu. Is there anything I can explain or clarify? And I do apologize that if the chat is not necessarily keeping up to date, so if you do have a question, I recommend that you just unmute and ask it in this case.
Could you explain C again?
Part C, yeah. So in part C here, right, we're using the 68, 95, 97 rule, right, and that says 95% of all of our values lie within the distance M, right? So instead of saying 2 standard deviations, they're just saying M. That's our margin of error, right? Of the mean of the sampling distribution. What is M? So this goes to our, from our notes yesterday, right? We have the, what do they call it? So we have our statistic, right? reset my pen widths. Right, the statistic plus or minus the critical value times the standard deviation. Right. This portion, the two things being multiplied, right? Those make up our margin of error. The plus or minus amount. Which in this case they're calling margin of error M. Since we know we're asked about the 95% region, right? We know from previous chapters that the 95% like chunk in the middle lies within 2 standard deviations of the mean. So M in this case needs to be equal to 2 times the standard deviation, because we have 1 standard deviation here, 2 standard deviations, 3 standard deviations. Right. So this goes to like when we first kind of got familiar with our normal distribution. So now we're kind of connecting back to that and saying, okay, well, if I know the percentage, and I'm like, in this case, we have 95%. I know that 95% of my data lies within those 2 standard deviations. So in this case, for this particular example, M equals 2 times the standard deviation to give me that margin of error. I hope that answered your question. Is there anything else I can clarify? All right, so we're going to jump back over to our Pear Deck. All right, and we're going to go to our next question. This has a few different parts to it. So question 2 is prayer at school. All right, a New York Times CBS News poll asked a random sample of U.S. adults the question, do you favor an amendment to the Constitution that would permit organized prayer in public schools? Based on the poll, the 95% confidence interval for the population proportion who favor such an amendment is 0.63 to 0.69. So this is an interval. So that means from 0.63 to 0.69, right, covers the 2 standard deviations on each side of the mean. Right? It's the entirety of that interval. So we want to interpret the confidence interval. Alrighty. Okay, so we're going to talk about this one. Many of you guys are on the right track. We need to be careful and be very mindful of the words that we use when we're talking about confidence levels and confidence intervals. So for this question, interpreting the confidence interval, right, we want to say something along the lines of they are 95% confident that the interval from 0.63 to 0.69 captures the actual proportion of U.S. adults who favor this particular amendment. If you say we're 95% confident that the interval from 0.63 to 0.69 is the actual proportion, that's not correct. Right? If you say that there's a 95% probability, right, that 0.63 to 0.69 has the actual proportion in there, that's not correct. Right? We're talking about confidence, so you're going to say we're 95% confident. Right? We have a large amount of confidence, essentially, that this interval contains or captures the actual proportion, right, of U.S. adults who favor the amendment. Okay, so the verbiage here becomes important in how we say things. If we switch out some words, it can say something that's not true. Is there anything I can clarify about this particular problem? All right. All right, so real quick, the other thing we can do with this type of problem setup, and I forgot to put this part of the question in here, is we can actually determine the statistic that was used, the p hat value from this interval, right? And essentially, it's because we know that this interval is 2 standard deviations away from that particular value of p hat, right? It's an even split essentially. So if I find essentially the average of these two numbers, or the middle value between the two, that's the value of p hat. So if I add 0.63 to 0.69 and divide by 2, we would get the point estimate of p hat being equal to 0.66. So we can kind of work backwards to determine the p hat value and then the margin of error, which would be plus or minus 0.03. Those are a couple of calculations that we could do based on the same context. Is there anything else I can clarify on this problem? Okay, go to the next one. All right, so the AP Statistics class in previous exercise that we don't need to worry about asked an SRS of 20 boys at their school how many pairs of shoes they have. A 95% confidence interval for the difference in population means girls minus boys is 10.9 to 26.5. Right, so they asked 20 boys and 20 girls, and they were able to calculate the difference in the population means, and they get that interval 10.9 to 26.5, interpret a confidence interval and the confidence level. So similar to the very first example we saw, we want to interpret the confidence interval and then interpret the confidence level. Alrighty. So we're going to talk about this one now. A lot of you have some very good starts or some very good responses to this question. Many of you are on the right track here, and your verbiage looks good. So that is excellent. All right, so when we're interpreting the confidence interval, right, this would be something along the lines of they're 95% confident that the interval from 10.9 to 26.5 captures the actual difference, girls minus boys, in the mean number of pairs of shoes owned by girls and boys. Right, so again, it's very similar to the previous couple of questions that we've had about confidence interval. We just want to use the right verbiage. For the confidence level, right, if we took many samples of size 20 boys and 20 girls from the school, about 95% of the resulting confidence intervals would capture the actual difference, girls minus boys, in the mean of number of pairs of shoes owned by girls and boys. So in the confidence level, you want to put out there that, okay, if we do this same thing over and over again, right, which would result in many, differences in the means, which would give us intervals, about 95% of those intervals, right, would capture what the actual difference in the mean of number of pairs of shoes is. Okay. So you want to have that part in there that we're going to do this a bunch of times essentially. And this would be the result. Is there anything I can clarify about this question? Okay. So there's one more question, I think. Yeah. I'm not going to have you guys do it. I'm just going to talk about it real quick. So we're going to go look at it. So with the same context as the previous question, does the confidence interval give convincing evidence of a difference in the population mean number of pairs of shoes for boys and girls at the school? And justify the answer. So the answer to this is yes. Right? Since the value of 0 is not in the interval, meaning it's not possible for the difference to be 0. Right? There is convincing evidence that there is a difference in the population mean number of pairs of shoes for boys and girls. So based on the confidence level in our confidence interval, right, we can be fairly certain that there is a difference, right, because 0 is not a possibility. Okay. Is there any other questions? Anything else I can clarify about this like introduction to confidence intervals and confidence levels? Okay. Alrighty, I'm gonna stop sharing my screen. All right. So that's the end of our practice problems that we're doing in class here today. The practice problems for 8.1 are available in Canvas if you'd like to see some other problems. I will hopefully have those solutions ready by the end of this week, so you can check your work if you like. I do apologize for the minor technical difficulties. I don't know why the chat is not working today. I'll have to restart Teams later. Is there anything else I can help or support you guys with today? Is there any other questions? Well, if there is anything I can help you with, please feel free to stick around and ask for support on those things. Otherwise, I hope you guys have an excellent rest of your week, and I will see you next week where we will go over 8.2 and 8.3. Right, have an excellent week and weekend.